Yeah, mind yourself. Yeah. Okay. Go for it. I'm here. Oh, and did you receive my new latest? Did you receive my latest bio today as fine with this update?
Welcome everyone. Tonight's event is the second keynote lecture of this year's 2018-2019 keynote lecture series on concepts, digital innovation in the built environment. My name is Eleni Papadonikolaki and I am a lecturer in building information modeling and management at the Bartlett School of Construction and Project Management. And we are very pleased to welcome Cristina Savian here today, this evening. Cristina is the founder and managing director of BeWise, a London-based consultancy firm specialized in helping startups and SMEs to scale up and bring new technology into the construction market. Cristina has over 20 years experience in the civil engineering and technology industries, working from small-scale traffic calming and parking schemes in the UK and Italy, through to planning major events, such as playing a key role as transport manager of the Greenwich Park venue during the London 2012 Olympic and Paralympic Games. She then moved to work for a multinational leading construction and technology firm that is Autodesk, covering several global roles as technical and commercial lead across Europe and America. Cristina started her career in 1998 as land surveyor in Italy and holds an MBA from the University of Cambridge, a joint degree in transport and business management from Imperial College London and UCL, and a first-class degree in environmental economics. Cristina is a regular guest speaker at industry events and holds judge and board positions on engineering and construction panels. She recently joined the Built Environment Industry Panel and the Institute of Engineering Technology. She co-leads the business case stream at the UK BIM Alliance, as well as being a technology scout for the Process Innovation Forum. Cristina is also an official ambassador for gender diversity and inclusion programs, and she is due to publish a white paper on tackling gender diversity in the construction industry with the Women's Leadership Center at Judge Business School, University of Cambridge. So before I give the floor to Cristina, just a bit of housekeeping rules as well. So toilets are back down this corridor on your left. A drinks reception will follow this ceremony after an hour. You are welcome to join us, so it will be just next room here. We're not expecting any fire alarm to go out, but if it does, just please exit with your closest fire exit, which happens to be here in this room, and follow the instructions of UCL staff. Please do tweet about the lecture and share your thoughts using the hashtag digital construction. Thank you for coming and enjoy the evening. Cristina, the floor is yours.
Thank you so much, Eleni, for inviting me tonight, and thank you so much for being here. So let's get started and let's learn more about digital twin technology. So the main question that I would like to answer tonight is, are we, an architecture, engineering, construction professional, ready for digital twins? And the main questions I would like to address tonight is, what is a digital twin? Who creates, manages, and operates digital twins? And ultimately, who benefits from the digital twinning technology? So, what is a digital twin? The terminology has actually been around for 15 years. It was first defined by Dr. Greaves, who defined digital twin as the virtual digital replica of a physical product with three key elements: the real space, the virtual space, and the connection and exchange of information within the two. In terms of early adopters of digital twin technology, it was actually NASA that around 1970s started using the earliest version of digital twin technology, which at the time was called mirrored systems. And this new type of technology not only helps engineers to solve complex problems with their equipment, but also helps them to prevent the faults before they even happened. And the same concept of the digital twinning and mirrored system is actually what was used during the Apollo missions and helps to recover the astronauts back from the failure of the Apollo 13 mission. So why do we think that digital twin technology is one of the top 10 technology trends for 2018? The current digital twin market is valued at around $2 billion and is expected to grow to a staggering, year over year, to a staggering over $15 billion by 2023. It's also predicted that by 2021, half of the large industrial companies will start using the data created by digital twins connected to IoT products and assets, and they will use the data to improve their performance, their organizational performance, which will lead, is expected to lead, and results in 10 to 20% improvement in effectiveness. So who is using digital twin technology? Pretty much all sectors are now embracing this new technology. We've just seen the market, it's huge. In automotive, Tesla has a digital twin of every single car they produce, which is connected to the car and is able to send its data across and self-repair itself. Manufacturing is heavily used in manufacturing. That's actually where it started. And I came across, for everyone, I was actually interested to see if actually we start creating digital replicas of bodies. And I actually came across, I'm really into fitness, and I actually came across this company who creates this suit, which is created with sensors and connected to your smartphone. It creates the digital replica depending on what sort of information is exchanged. Then it optimizes your fitness regime, and which allows you to reach your goals faster. So we will see digital twins technology used in pretty much every single sector across the board. So what are the benefits of digital twins? The ability to have a virtual replica of our products and connect it and have real-time exchange information can help us to manage the entire life cycle, for our case, because construction, for example, will be assets, and improve the performance across the life cycle, reduce cost, improve the efficiency, and as we noticed, even manage to predict faults before they happen, and ultimately operate and manage more efficiently. So this is a real case of application of digital twinning technology, real-time digital twinning technology. I had the pleasure to meet the current CTO of Wood, Darren Martin, a couple of months ago. Wood is a multinational energy service company, which is headquartered in Aberdeen. And he explained me how they currently use digital twinning technology, which is in 4 stages. They currently have a digital replicas of their pipelines that helps them to distribute their oils and other liquids from source to the terminal. And the pipes have sensors that detect the levels of whatever they're transporting. And whenever the sensor detects that there is a change in levels, they have 24/7 autonomous drones going in a loop, and which are sent immediately to the location to assess what is the cause. Okay, it could be a leak or it could be another reason. So depending on what they can see, they then decide if it's safe to repair or any other actions has to be taken. And here we can see how immediately the benefits of real-time digital technology is currently used in the oil and gas. So, how do we create digital twinning in the construction industry? This is the very typical building life cycle of a built asset, and which all of us as construction professionals are very familiar, but we do have people in the room probably never seen this. So the life cycle starts from the planning phase, then we go into the conceptual phase, the detailed design, we go into the analysis, fabrication, construction, then we operate our assets, and then the life cycle, either which can be really long in our case, in our industry, 50, 100 years, ends either with the demolition of the built asset or the built asset is renovated and it goes back. So, and the main three phases of the construction process, actually the life cycle, are the design, the construction, and the operation and maintenance phases. So, during the design phase, we want to create a virtual replica. This is actually when we start collecting all those useful information that if we take through the rest of the life cycle, by the time we build our asset, we actually have the digital replica. So if we want to create a digital twin, all we have to do is take all the information across the life cycle of the project and connect it with sensors to create digital twin. Great, so we can do this too. So how do we go to create virtual replica? How do we actually do that in practice? This is just an example, small number of the different type of roles and professionals they work across the life cycle, which exchange the information across the life cycle in many phases, different phases, and the exchange of the information not always in a very organized matters, and which is nowadays is mostly digital. Okay, so they do exchange digital information. So what we need is a coordinated effort by every single professional that works along the built asset, the building information life cycle, to coordinate the effort with their digital information to help create this virtual replica. And do we have a process that helps us to manage the digital information across the life cycle? We do. And it's called building information modeling. And for everyone who's never heard this terminology before, is actually building as a verb, not a noun. And this defined process helps us to manage in a structured way the information that goes across the different phases and across the long list of stakeholders that work around the industry. Great. We have a process, we know how to do this, so let's do it. And this is actually when I want to share a situation that I actually come across quite often these days. And a couple of months ago, I went with a client to visit one of the brand new office buildings in the city. Brand new building, smart design building, I'm going to explain in a second what that means. And the office just been, occupied, and we visited the head of facility management, and who obviously, is operating the building, and we asked how they currently use the over 200 digital models, 3D models that were created during the design phase. And the answer was, we never opened them. We actually don't know if anyone ever updated. We have it's a huge building. We are not actually sure, and we actually don't know how to use them. There's too much data. We need part of the data. We don't know how to extract the data, so we're not using it. Something went wrong there. We have opportunity. We have something that looks like or part of, our virtual replica that somehow we lost. The other interesting part is, as I say, this is smart design buildings. It means it was fascinating. It has a lot of sensors in each room that detects temperature levels, oxygen levels, the level of, if it's occupied. And what was interesting to learn is that we already have a building actually, an existing building, physical asset, we already have the sensors. So all we have to do is we have to connect it. And what was also interesting is to learn that the platform that's supposed to gather all these amazing sensors, the insights, and give insights of actually how the building performed, was still currently in development. It was not even finished. And unfortunately, I keep coming across this scenario, okay? So this is not an atypical scenario. And the reasons why this is happening are many, and we can discuss later in the questions. This is actually a good case. They actually used or tried, to use and did the best to follow the building information process. They actually used the latest technology, which actually allows them to create these 3D virtual models. In many cases, they don't exist. So this is actually a good case, but even when we start using them, something went wrong, and we do have some challenges. And as a construction base, we know that we do have some, we have some serious challenges in trying to get the virtual replica created and maintained along the process up to the operational maintenance phase and linked to the sensors. We can start listing some of the challenges. Legal framework, how we currently procure construction. Industry practice. We always done it that way. Why do we need to change? The very, very large number of professions that actually work in construction and along the construction process. The lack of interdisciplinary collaborations. How difficult, despite we now have the technology that help us to collaborate in a project. This technology was not available a few years ago. In the last, we have now the proliferation of all these amazing collaboration tools, design tools, the number of software being developed in the last, decade is staggering for the construction market. And despite we have this new technology available, which is the enabler of the building information process, we are still struggling. We're still struggling to create a common language in a common way to get the information, to gather the information across the life cycle. And of course, interoperability, because yes, so many software, so many tools, they're not necessarily that easy to exchange information between them and between the different platforms. And here is the key question. Who owns the data? Why is this happening? And in the case they are giving you, do we trust the data? Even when we have the data, Can we trust? Do we keep ownership of all the data, all the different stakeholders that updated this data? Because the reality is, what happens in the industry is we fight over the data, even when we have it. And for some reason, we're afraid of sharing it. If we start applying the building information process properly, we have the opportunity to create a virtual replica which can be connected to our physical asset, which will start allowing us to, have real-time asset information, which will allow us, if we start connecting multiple digital twins, ultimately create smart cities. And if we start analyzing the data with those, between the smart, with the different, ecosystem of twins, digital twins, then is when we can actually analyze how our built assets are actually used. So we can benchmark, we can give back that information, ultimately create and build, better and more efficient buildings and infrastructures. So here is where we have the digital twin. It is, the enabler of this virtuous circle. So in the construction, we have many challenges, and one of the biggest challenges is the increase of demand. Our population is growing. We need more buildings and we need more infrastructures, and we still need to renovate also everything that we already built. But one of the other major trends that's happening is the fact that we actually reached the low bottom quartile profit margin in the industry. We are second only to agriculture, okay? Which is putting a huge pressure into the industry. And we already all know as an industry that, examples like the collapse of Carillion, and yes, it was in the news. We now have Intercept, which is risky. So, as a construction professional, we also know that all the projects are overrun and always late. We need to do better than what we have, okay? And we can't keep carry on the way we're doing. So here is the opportunity, the digital twin opportunity. Digital transformation is happening. And it's driven by people, no government, no politicians. And the decision-making process is driven by the availability of structured data that allowed us to create, manage, and operate assets, which ultimately can create a better environment for all of us, and ultimately can help to improve the life of all the citizens with the creation of smart cities. So ultimately, the beneficiary of the digital twin is us. It's all of us, not only as a construction professional, but as a human being, as being the users of a built environment every single day. But we do face as many challenges on actually creating digital twin, applying and benefit from digital twin technologies. And we did talk about industrial practice, we did talk about common languages. Digital twin also brings new challenges. Data security. How can we safely connect devices? How can we ensure that nobody is going to breach, is going to have the information on the built asset, on buildings? There's certainly some serious security risk there. And also the cost to develop and maintain those digital replica. It's something that it's an important aspect. The legal framework, how we we meet our contractual obligations. But to realize the full values of digital twinning, we need to coordinate across everything industry. And this is an example of UK embracing the digital twin benefit. I'm very lucky because I actually, as soon as I posted on social media I was going to do this talk, Mark Enzen, CTO of McDonald, one of the large multinational engineering consultancy companies with a headquarters here in Croydon, actually approached me and said, the Centre of Digital Build Britain is actually just about to publish this paper. So this was actually published on Friday. And it basically it sets the values, it brings academia, government, and professionals all together. It was set up by the government to help and drive the digital transformation of the construction industry. And the paper set the fundaments and, and the values to guide the development of a national digital twin. So an ecosystem of twins connecting and exchanging data. And what was interesting is also the benefits calculation. So actually calculate the greater data sharing could add 7 billion pounds per year just in benefits, which is 25% of the total infrastructure spent. So build digitally before we build physically, it's an opportunity to improve the efficiency of the entire network. So this is what we learned tonight. The earliest versions of digital twins send people to the moon. We are still debating if they are in any use here on Earth. Digital twins are widely adopted in every single sector, but we do face many challenges in the application and creation of digital twins in construction. And to create a digital twin, we need a virtual replica with a physical asset connected through sensors and IoT devices. But the question that I ask myself, and the reason why the question actually keeps myself up at night, is if digital twins could have prevented these accidents. And the first one is probably very familiar to all of us Londoners, when on the 14th of July, the Grenfell Tower went on fire. The second one happened 14 months later, on the 14th of August this year. And this is something that brought back many memories, childhood memories, because this is just a few kilometers away from our hometown. And this is the Ponte Morandi that on the 14th of August collapsed. And the reality is, I think, yes. The answer is yes. Digital twin technology could prevent this. Thank you very much for the chat and listening, and I'll be very happy to start taking questions. I have a very long section on how we actually make digital twin technology happening in the construction industry.
Thank you very much, Cristina. Before we give the, we allow the audience to ask some questions. I have some questions on your presentation. And actually, I really like what you said, that we were able to use digital twins to go to the moon like decades ago, but still we haven't figured out how to do it now in the construction. I was wondering, what is your thoughts about user engagement? Because we typically hear, especially when we talk about smart cities, that what makes or breaks smart cities is user engagement, and to what extent people in these smart cities, they are recording, maintaining data, and they're doing what a smart city citizen should be doing. So what are your thoughts on that?
Well, in terms of users, the reality is we all like to be connected. We like to have the information available, but this information has to be created and maintained by someone. And in terms of the smart cities, somehow along the process, someone doesn't want to take ownership of the data. That actually allows us to gather the important information about the asset. So we want it as a user, but somehow nobody wants to bear the cost. We don't want to bear the cost because someone else created the built asset. Why should I pay for it? So how do we actually break that cycle? How do we actually make it happen? How do we empower the owner of the asset to actually manage the data and ensure the data is managed across the entire process so they can operate and maintain the asset better and ultimately give the end users the information they need.
Thank you. Thanks. Any questions from the audience? Yes?
Yes, it is. Yeah. So thanks, Christine. That's really interesting. I had a question. I wanted to ask you about ownership of digital data. Because as I understand it from your model, many of the benefits of digital twins and virtual twins comes from pooling them, multiple digital assets. How does that tally with the construction industry in the UK, where 60% of built assets, and you presume physical and digital, are both going to, the ownership, the presumption is the ownership is the same, are privately owned. So how does the data get transferred into the public realm?
So this is the benefits that I discussed at the end, which it's very interesting because when I started gathering the data for this presentation, it's not actually easy to actually find the calculation of the benefits. And for all of us in the industry, we all know also how difficult it is to find data that even explains the BIM, benefits and the use of that process. And we all know about the PwC reports, and actually, those calculations are not actually easy to gather. So this is the reason why we liked, and I actually went back, and one of the questions was, how do we calculate that? And then it's just been published. I still haven't managed to get the information actually that was calculated. So this is interesting because I actually say, okay, we are already struggling to create one digital twin. How can we possibly start connecting them? And this is interesting because this is actually for infrastructure, which is public. So it's in the moment the owner is one and is willing to share the data. If we manage to share the data in a very secure manner, probably can be solved. But it's interesting because in the private, so let's say a private, building, it's the owner that's supposed to take ownership and say, hold on, this is what I own, this is what I have to maintain for such a long time, and I want more. The reality is what happens is they actually don't know they can get more. They don't ask for more. The professionals keep doing what they're doing because they've been doing this for so many years. Why should they change the process? Which also provides and creates another different problem, because one of the problems is also the upskilling, to the digital. Digital savvy, get all the professional industry, to start embracing digital transformation. And it's challenging. We know, I explained we have very lowest profit margin we ever had. And as a construction, as a owner, what do you do? What do you do when you have to run a business? You have to try to make it work, and it's either paying your employees or upskilling your employees and trying to actually get benefits, across the life cycle. It's it's very complex problem, and that's the reason why it's not an easy one to solve. It's something that we have to educate, and we have to educate as end owners. They can ask more, they need to expect more, because now the technology is there, it's available, it just needs coordination.
What part does standardization and global or international procedures play in this, and what are the risks involved with developing everything into the same language and having data easily accessible?
I did add standards as one of the challenges. And then I say, okay, let's try. I'm sure I'm going to get questions. And the problem is, yes, there are long lists of international bodies. They are trying to coordinate the way we talk and we exchange data. And that for all the industries, we know we got a PAS 1192 that explains clearly how we're supposed to use, this process. And we also have the new ISO that just came out. It took 4 years. 4 years to coordinate effort, huge effort, because I know the people involved. From Ankel to Paul Chico, they all got involved, worked really hard in developing that standard and create a common way, to talk. Can we afford the time now? Can we afford to spend 4 years to develop, a common language? We need to try to find a better way, because we already seen, accidents are happening and infrastructure is failing. We need new homes, we need new infrastructures, we need to embrace digital technology faster in the construction industry. And yes, the creation of common language, it is there. We have standards, we have FSC, which if we ask all the software developers to start, allowing the software to start communicating the same language, it takes years to develop. And it's challenging. It's challenging because we are on the verge of a collapse. We have to do better more. We need to try and find better and quicker solutions.
First of all, thank you for the presentation. It's amazing. The example that you mentioned about wood is also inspiring. I have a question if you have any other example where, for example, in an infrastructure project where the government implemented digital twin or any other inspiring example.
Yeah, it's interesting because I actually looked into it after the accident happened in Italy. And I actually could not really find a good example of this good. So, no, I don't know. If any one of you knows, please let me know. And now, obviously, the general principle has been published, and hopefully we're going to start hearing more on actually how we create these digital twins. It's very interesting that actually, seems to come mostly from the public sector and the government, and for our infrastructures, as we know, it's it's failing. We need to renovate it. The calculations of how cost to maintain this infrastructure were all miscalculated, and that's the reason why, for example, the Italian incident happened. So I don't know one of the a good example. If anyone knows, please share with me.
It's hard to do too without using digital as a methodology at the moment from the inception phase right over to operations and maintenance. Because from my experience, I believe that the government, that their high-speed tourism organisation, is mandating that should be the case.
Yeah, I don't know the high-speed case. I will look into it and see if how it actually gets applied. I think probably, from my research, we will start, seeing more of digital twin, application of digital twins. It's a matter of to what extent, if it's going to be start with part of it, which ones are going to be the built assets, they're going to have sensors before than others, they're going to have their digital replica. And it's probably on how quickly we can solve all these problems. And yes, easier when we have an owner, easier when we have someone who is leading and say, as an owner, yes, I want this, and yes, we will find a better way to share this data because we have to, because we don't have a choice.
Thank you for the presentation, that's great. Just a quick question regarding your view of the kind of characteristics for the client that should start embracing digital twin and following that approach. Because we find it a bit challenging. You're coming up with great let's say technology or processes to make things optimize them better, but the clients don't seem to be willing to embrace that kind of stuff. So thoughts about characteristics?
Yeah. It's interesting because I actually spoke to some investors a month ago, and I said, well, hold on, you are the client, you're buying this. Oh yeah, I might come to your talk because I think we were looking into them, but we've been told it's more expensive. So why should we? Then I'm here just to make money. And then is the business perspective. That's the challenge. That's its the education to the client, and as a construction professional, we need to educate that yes, there might be the cases where it'll be more expensive because we need to go through the bump now to upskill ourselves, to try to do better, to coordinate in this process. And yes, for everyone used to the design and construction is the CapEx phase, might need a bit more investment, but in the long term, the OpEx is also where we will benefit, and we will benefit as an end user. So my answer is educating the client on why. And I think one of the struggles is having clear stated benefits and calculations of how beneficial it is for the operation and maintenance phase to actually have better data that allows you to maintain and operate the asset better.
Hello, thank you for the presentation. I've been very interested in how you're actually getting the data from one common data environment to another because it's an enormous amount of data, and we are struggling as it is at the moment just to move unfederated models between common data environments, be that private, be that public sector, how that interface works. Then secondly is then how do you access it, because there is, I don't think, correct me if I'm wrong, a standard naming convention that actually describes the different levels in which these models should be interpreted and ruled to. Two questions.
It's a difficult technological challenge. Standards are the creation of the common language, and it's one of the current issues that is still not being fixed. It's still a challenge, and in terms of naming convention, I actually have been with an expert, so I'm actually going not to try to answer. But it's a challenge because there are many professionals. It's a very fragmented industry. There is there's too much out there, and the coordination is difficult. The creation of standards, we explained, it's very difficult. The exchange of information, and the creation of this common data environment and the way how the data is structured, it's all based on how the software, vendor decided to to create what based on. And each one of them worked for software developers and work with a lot of technology companies. It's challenging to to develop software that worldwide adhere to all sorts of different type of standards and that might be out there. They at the same time try to speak the same, language in different countries and where things might work differently, and then coordinate on actually how professional one is in the moment, which is not necessarily how the standards actually are implemented out there. So it's technology challenge that we still haven't answered. We still haven't. That's one of the main problems why we have a process. We have the technology available that allows us to, but we still struggle. And I wish I had an answer, but it's one of the main challenges we have to solve. Yes.
Do you mind if I just
go
say
for it?
Really quickly? Any language is better than no language. So data can be mapped as long as there is common logic within the way that it has been mapped. One of the biggest problems that we have is that within a project we'll follow lots of different protocols, or we will name the same item with 3 different names because we've got 3 different subcontractors building that item. So long as there is logic, the technology is there then to map that into other systems. We can take huge amounts of data and basically pick it up and move it somewhere else very easily. It's actually more to do with the intricacies of the naming itself. But don't get too bogged down with following a certain standard at the moment, as long as you are following a logical standard. And also, in terms of a digital twin, the benefits are huge from very small examples as well. We don't necessarily have to look globally or across a whole country or even a city to see the benefits. It can just be the benefits of having one tiny building, a digital twin of that. Sorry.
Thanks.
Hello. Could I just ask a question? You made a point about the quality of data, which we haven't really spoken about in the Q&A. I'm just interested to take your Grenfell example and how that can change. So if I'm a subcontractor on a project, I'm aligned to a manufacturer who is supposed to have developed fire certification for a certain element of the building, that manufacturer has no connection with the project as soon as the documentation is handed over. Just interested to get your thoughts on how do you keep those people responsible for updating, whether it's digital twin or an O&M manual. How do you keep them in there?
It's challenging. We were discussing this in the high-rise hackathon a few weeks ago, where we actually heard about the Greenfield inquiries and how that is progressing, and we could have done if technology could have helped, and how. And there are many different. I'm not a building expert, actually, as mentioned, it comes from the construction world, so actually discovered many things they actually didn't know on actually the building process. And there was one of the questions: how do we ensure the clarity and the transparency of the process? Because what actually was interesting from just getting updated the inquiries is there are many standards, and everyone is adhering to the standards. There's nothing really wrong with what happened, but somehow a combustible product got there. And how it got there and how we allowed that to happen, is the question. So could have better tracking of and the embracement or better organized structured data along the process, where all the suppliers are enforced to provided, those information which are taken through the life cycles. And the moment we have the operation and maintenance phase of the buildings, we can actually simulate. Maybe if we had a digital twin at the greenfield, we could have simulated the airflow, could have simulated fire, trying to understand what would have happened. Maybe he would have simulated, we would have picked it up. Same way as the evacuation procedure. We could have, digital twin probably would have prevented them and would have detected them. Maybe the central staircase, it was going to be a challenge, or the procedures on the stay put. There's a lot going on there. Those events are definitely changing the industry. It was extremely interesting for whoever designed and built buildings now the extra procedures and the extra process they have to go through because the incidents, and we're trying not to repeat. So it's going to take a while before we probably coordinate the effort. The reality is we start gathering the data and we start structuring the data, that somehow it's a logical matter, because we will have new standards, we will have a new way, in a few years, and we can reuse the standards and we can reuse the data, and long term, it's, probably is when we can start, have better understanding of actually what we have there, and used in the building.
Can I ask
Go.
a controversial question?
Okay.
If, to use your NASA example, NASA, you can be sure, have the power and the influence to standardize all their supply chain, that they dictate exactly what they want and what they do with that information. So to bring that over to the construction industry, do you see an opportunity for an outsider to come in and disrupt the industry and do it instead of everybody else?
So it's interesting. We managed to coordinate standards for aerospace, for planes, for these type of products, but somehow we are struggling because of different countries, because we're talking about big assets which are designed in a certain location with certain specifications, and there are also different cultural ways of buildings, and we just do things differently pretty much everywhere, which it complicates the problem of trying to standardize away, because the buildings in Italy are completely different the way how they're built here, and the materials are completely different, and this is across the entire world. So how do we start coming and trying to coordinate that effort? What happens is we already start having seen 3D printed buildings. We already start seeing that actually we can manufacture part of the buildings, and perhaps we can start standardize certain aspects which will help. So we probably get used on having certain aspects of the buildings or the assets done in a certain way with certain specifications, not huge variety, but maybe less variety if possible. Could someone from the outside start disrupting? I'm not sure. I'm not entirely sure. Yes.
Thank you for your presentation. I have a question regarding the momentum which BIM is gaining in the industry. So there is a national mandate by the government for using the BIM on the public infrastructure projects. So when we look at this new concept, digital twin, so how do you look at that getting embedded inside those standards, or will that be the future of digital twin, or will this emerge as a different challenge like the industry is facing with BIM? So what's your view on the solution for various challenges with this concept?
So we do have the process, which is the building information process, which allows us to follow it the best we can, to manage to create in a structured manner and gather all this digital information in a very organized manner along the entire life cycle, enable us to create these asset information models that, as we saw, if we connect to the IoT device, can create our digital twin. The problem is the challenge that we have in the industry, and despite we do have across many countries BIM mandates, so the government is actually saying you have to use this process because this process is an efficient process and this is how it should be done. The reality is the industry not necessarily works this way. It might be the best way, but the industry, as industry professionals, we all know it's actually much more difficult than the theory. Yeah. So the practice on actually start working all together, despite we now have the technology available, it's difficult, and it's the digital twinning. Can we create a digital twin without following the BIM process? It's it's a different question. I see it as an enabler. So if we follow and we try to solve all these challenges along the process, we can create those virtual replica, because the reality is if we follow it, and as we already have digital information in somehow structured way. We have already these 3D models that if we update and we maintain and we across the life cycle, they are virtual replicas. So even when we went into such a huge investment on create those models and trying to follow the process we're still not used, and this is because of many other challenges. So it's more the embracement of the purpose of why are we doing this, rather than just looking, we have to do the BIM mandate because it's mandate and that's what we're supposed to follow. It's more what is our end goal and what are we trying to achieve. And the reality is, if the digital transformation is happening, all the industries start embracing the benefits of digital twinning, and we should, as industry professionals, for the benefits of all of us, start using it as well. So we need to find a better way to embrace, to resolve the challenges and embrace the process.
Okay. Thanks. We'll take one more question.
Okay. Okay. Last question.
Yeah, and I'm going to be the skeptic in the room.
Okay, fine.
It's impressive for you, given the start of your presentation with the NASA project and spacecraft and digital twins being there for many years, but we failed to use them in construction. I kept thinking about that first slide, that spacecrafts are meant to be used by scientists and engineers, whereas in reality, construction projects are maintained by asset managers, facility managers, people who are not engineers. So a digital twin in the context that you displayed makes perfect sense, because engineers design and engineers operate, but in construction that's not the case. And in reality, for infrastructure projects, software like Maximo, Ellipse, so on and so forth are already there. They've been used for the last 40 years or so. They dumb down the 3D model to a repository with metadata, and that's how they run. That's how they operate. So I'm not sure why do we need a digital twin, and how we can convince the clients and operators to buy into this concept, especially when the industry is quite skeptical with regards to the value of BIM.
So it's not that skeptical, it's how we solve this and how we sell the benefits. And we can use the virtual replica, do the design and the construction phase. We gather this information, and we are experts, and we want to analyze how the asset performs. We can. In fact, one of the answers that was given on why that very nice, good-looking smart buildings and why the models were not used is because they didn't know what to do with it. Because they're not experts, they're just, they work in a different way. And the key is the extrapolation. If we have structured data, and even if we don't want to visualize that information as a 3D model, we don't have to. But if we want access to that information, and the information is there and is organized and is structured, I can search as any other search engine that information. I don't have to be an expert to use the data. So the problem is structuring in a way that then can be queried very, very easily and can be used by non-professionals. So I think that is, it's how and why, despite with the process, despite we are already creating some sort of digital replica, we actually struggling to get through the entire life cycles. Is because the end, and also it's how do we sell it, to the clients? And the reality is, if we show the benefits brought through the entire life cycle to the operation and maintenance, where it's easy for even a not professional, for a professional in that industry, but not an expert in terms of actually the architecture and engineering functions, and can use and operate and assess and maintain, the asset. That is when probably we are going to solve, the problem and the issue. Thanks.
Okay, thank you for this. It was nice to end with the why question.
Yes, thank you.
So this concludes our session.
Thank
Can
you.
you give a round?
Thanks a lot.
So drinks and reception are next.
Thank you.